Hello everybody, and welcome back to another lesson. Today we're going to be studying animations for our steam boiler. So, last lesson we built this thing, remember? And so the animation we're doing, oh look, it's tilted. Okay, there you go. The animation we're going to do is we're going to animate coal particles, pieces of coal going down here, into here. Then the end of last lesson we built an ash cart, another ash cart over here collecting the coal. So it's gonna go. It's gonna go down here and into here. So let's start. Class coal particles. Coal particles. Obviously, let's start with initiation. And in your code, if you want to remind yourself that this is for the animation, you can put a little comment. I don't know how to do it. So, tilted first. It goes great slat 00001 tilted mid is great stat 11001. If you're wondering what these are, let's see. So here, great slot .001 is this. So why is it tilted again? So when we say great slot 001, we have top, so that's the first little slot of this great. Tilted mid 11.001. There it is. And also 0.001 is this one. Regular without the 0.001 is this. And then, well, we have a first and the mid. We're going to need a last. And there are 23 grates here, so I split wrong. There. Okay. So that's the first, middle, and last stats of the tilted. Now let's do the midpoint. Flat left, great slot 0, 0. So the first one, middle, mid, great slot 11. Remember, because there's 23, so 11 is the middle. And then right, great slot 23. Dash name, let's call it ash cart. Copy. Total frames per particle is 80. This, you can change it to have your steps. Tilt is 8 steps. And you'll see what these mean very soon. Okay. Now, self.names. So let's have variable names for everything. Tilted first is going to be tilted first. So we're naming everything in Blender. Tilted, so this thing, like over there, tilted mid. This tilted mid, and I need a comma. Tilted last is tilted last. Flat left is you get what this is. Ash is ash name. Was I okay? I have to close this. And let's see. Okay. Oh yeah, we have to like use it first. Okay, this doesn't work. Yes. Yep. So self that total frames. Put into integer total frames per particle. Self dot steps tilt is integer steps tilt. Self stuff is steps flat. So these self dot radius goes here, and then depths before that context that evaluated depths graph. Okay, and you'll see what this does. Wait, actually, let's make some helpers first before I get into that. Okay. So let's first of all build waypoints for the animation. So T0 first redstone is slot top. Wait, we don't have slot top, don't we? Yes, because I got confused. Okay. Never mind this again. Slot top. Okay, so we have to define the top of each slot. So because the coal is rolling on top of the slots, not like in the middle or the bottom. It's just stays on top. It keeps rolling to the top. Z offset 0.01. How did I get up there? Okay, whatever. 0.01. Okay, and what this is going to do is return evaluated world space top point for this slot. So for any slot, it's going to give us the top point. Evaluate object is ppy.data.objects.get self name. Return vector eval object location.x dot location.y eval object dot location dot z plus z offset. So we have this offset, right, and we have the x and y of the top part, but then I forgot the dot. Yeah, it adds 0.01, which is how tall the slats are. Look at it. Okay. Which would get you the top point. Okay. Now that we have this design, now I can do the thing I mistakenly did earlier. Which is the waypoint builder. So let's define build waypoints self. T0, so the starting point, is slat top of tilted first. So obviously the coal is starting from the very tip of this slanted part. That's why T0 is the top part of that. T2, and you may be wondering why I skipped T1. It's because I originally had something else for T1, but I realized I didn't need that. And I'm too lazy to change everything, so yeah. It's T2 now. That's laptop is tilted last. So T1 was originally tilted mid, which you don't really need, but so we don't even have the middle. But if you want it, if it's your preference, then you can use it. FL. So flat left, that's what it's called. This is tilted 0, tilted 2. Flat left. Hopefully you know what's happening right now. The coal goes down to this thing. Goes to the flat left. Flat right in. So obviously there'll be a FM flat middle in between. But we don't have that. So that's flat top, flat right. We have the hash card because it still goes into the hash card. UPY.data.objects to get self.names hash location. So we get the hash card's location, and then hash inside is vector. So we define the inside so that the code can fall in. So the x and y values will be the same because the hash card still is in the same way. But we have hashcard.z, and it's going to be slightly lower than the original z value, which is the middle. Now let's create a list for the waypoints. So the animation for this call. So first, for the tilted grid, T0 to T2. For I in range, for the number of steps in steps.tilt, not steps underscore tilt, we have U, which will be important, is I divided by self.steps underscore tilt minus 1. Oops. This is a fraction. Well, I is 223, right? Actually, no. That's 8. So this is a value. It's basically, the I obviously goes from 0 28. Oh no, or 128. And then it's divided by this. So that steps tilt minus, okay, so it's 0 to 7. Steps tilt minus 1, so it's a fraction that goes, which means at this bottom is 7. It's a variable because we can change it just by changing that value. And it's a fraction of 0.7 to 1/277, which is 1. So every time this for loop goes, it gets slightly closer to 1. Waypoints dot append t0 dot lerp t2 u. So what this LDRP thing does is that it does interpolation, which basically goes from t0 to t2. It defines new points from t0 to t2 based off of this u, rather the fraction. So it creates new points based off of these two, which if you may connect to animation, obviously when you have like frames, and it gives something similar. So that steps flat. So we do the same thing, except it's flat. Waypoints dot append fl dot the same thing fru. And points is equal to length of waypoints. And I did not spell points correctly. Actually, wait, let me abbreviate it. Compute frame offsets evenly across total frames. So we have all these new waypoints, right, that we put in this list. So points from there and then to here. Now we can like put in some frames for them. Frame offsets integer round I times self dot total frames divided by n points minus 1. That's too many. I don't need a space there, and I need an equal sign. Oh, order of operations, I need another one here. For I in range and points. So we have the length of the list, so the amount of waypoints there is. We have this one. We have I times the total number of frames divided by the number of points minus 1. So it's a fraction for I. So this in range of the endpoints, so it cycles through the number of points there are, gets the number, multiplies it, all frames, minus this, which would get Oh, well, it should get bigger because frames will be longer. This is a whole. This is larger than 1. And then it's an integer. Also, you round it. What should get frames? Which should get us frames for the waypoints we defined. We can return waypoints, frame offsets. Where's there? Put them. I didn't indent these correctly. I don't know why that happens. Oops. Oh wait. Okay. These are good. Okay. It doesn't solve it. No, it doesn't. Okay. Um. No, it's this thing that's the problem. Okay, it solved this problem because Python is sensitive about indents. What's this? Imagine equals. Okay, it's minus. I put in equal sign instead of minus. I never close this. Lots of typos here. And indentation error waypoints. Oh, I need to make an equal sign. I keep forgetting the equal sign, so okay. As you can see though, nothing happened. But that's all for today. We're going to continue expanding on this animation next time. Bye.